record it to make sure we record. Okay, so yeah, please remind us anytime so that we don't miss recording. So what the course is all about, as you can see, the course we say natural language processing and large language model, right? So it's some kind of two things we're gonna do. In those early days, prior to Transformer and recent development we are doing a single course natural language processing where we talk about NLP. But nowadays, NLP has moved forward. It moves from natural language processing, and now we are in the era of large language models. In fact, some schools they are just using a course called large language models, and some schools are using two courses. They will do the first course called natural language processing, and the second course they will do large language models. But our intention here is that we divide the course into two: natural language processing, where we take the very basic NLP, then we move into the second part, which is large language models, where we do it. And this is subject to change. Everything here is subject to change. Here I did this course in South Africa, me and Dr. Idris. So everything is expected to change, including the slide and whatsoever, but we will update everything for each week that we cover. And the plan is to do this bi-weekly. Bi-weekly meaning that we're gonna do this on Saturday and Sunday and the same time. And the reference we're gonna do is, if you see this book, which is natural language processing. So this, if you are learning NLP and you are at the beginning, the first place you're gonna do is just the book. Yes, this is just the book you're gonna start. So the book, you can see that it starts from here to here, and you can see here they now call this section large language models, right? And if you look at the book previously, it was called speech and language processor, right? Speech and language processor. But the volume one before this, because this is continuous, you can see they continuously update this book, is with somebody called Dan Jorapsky from Stanford University. If you Google, he does a course for NLP. Let me just show you this course from John Jorapsky NLP course. So he did a course in Coursera. Um, he and Chris Manning. So if you don't know who is Chris Manning, these two people are the top guys in NLP. Chris Manning. Maybe I will also add some picture with me with Chris Manning in one of the ACL conference I attended. So if you look at this one, this is a course, NLP course they did. If you go to YouTube, you can see that. NLP, you can see 7 years ago, right? Introduction to NLP. You can see the course is called Introduction to NLP. And you can see it started from chapter one, regular expression, word tokenization, normalization, everything. You can look at it very, you can see up to 7 years. And they follow this book from the beginning to the end. And you can see here, previously, what they call the course is Introduction to NLP. And you can see the chapter, they start NLP regular expression. But due to the evolvement of NLP field now, many things are becoming obsolete. And they are updating the book. And now you can see the book has now changed from the natural language processing to large language model. So it start from Ngram and whatsoever. You can see RNN, transformers and something. And here is about annotation. And here, some stuff that they already moved them to appendix, such as naive Bayes and everything here. They moved them to appendix. So if you want to have if you want to get this PDF copy of the book, so you can come here. I can download the book here and share with you guys. So if you let the book open, and we can see that. So obviously for me, those days when I started doing my PhD, I went through this course online. I went through them from the beginning to the end to learn about the introduction of NLP. So this is the book. You can see speech and language an introduction to natural language processing, computation, and speech recognition with language models. So you can see this is the third edition. And so this is the first thing if you want to the book. Now, but this book covers some stuff like that. But we also have new books. Number one is hands-on large language models and LLM from scratch. So this book is also a good book that we will be using. LLM from scratch. You can see it. This is a very interesting book. You can see it 4 stars in GitHub, and you can see the book Large Language Models, Build Large Language Models from Scratch. We expect at the end of the day, each one of us here will be able to train his large language model LLM. Small LLM, you can train like the way you see you have like, GPT and whatsoever. So we're going to have you train your GPT, small GPT to learn the pipeline, how to do that, how to do fine tuning, how to do pre-training and all those class stuff. So this is the second part of the course. There is also another good book, which is Hands-on Large Language Model by JJ Alma, which is also good. But also one of the interesting book we have is by Tom Moore. Let me see. Tom Moore. That's this guy. Yeah. Let me see the book. Yep. Yeah, large language models. This is the book, Large Language Models. So this is also Introduction to Large Language Models. We will refer to this book. So just to, tells you a bit about what we'll be doing in this class. But let me share our slide and then we can start as well. Let me share the slide. So as I've said that this slide was prepared, I prepared this slide and I had also Idris that helped me to, okay. Can you see my slide? Hello?
Yes,
Yeah.
it's very visible.
Okay, you can see, right?
Yes. Yeah, sure. You can go ahead.
All right. So, as I said, this is slides I adapted from my last class. You can see things have not been changed, but before I push it for this class, we will change other stuff. So a little bit on myself, as you already know, for those of you that are not here in our previous classes, my name is Shamsuddin Muhammad. I'm also one of the, founders for Ario Data Science. And basically, I'm interested in NLP and also, interested in, working in the community. So this is my profile and, Idris also is, part of co-founders for Ario Data Science, and he is currently a postdoc at University of Pretoria. As I've already said that natural language processing is basically, we know it's a task that allow us to work with text, but
Hello, doctor. Sorry to interrupt. Your slide is in speaker mode. I'm not sure. It's like you're using two screen. If you can check it.
Sorry?
It's on the speakers mode.
Oh, the slide is in. Oh, okay. That's not the one I was discussing. It's okay. You can see it, yeah?
Yes, now it's in presentation mode. Yeah, correct.
Okay, perfect. So the large language have now, transformed these fields to, have something new, not necessarily to have only large natural language processing, but now we need to combine both the old ways of using NLP and the new ways. So the old way, as I've said, is what we call the natural language processing, but the new ways for doing NLP, you hear people saying large language models. So we're going to have these two. So these are the prerequisites for this course. As you already know, we do have, Python, machine learning, deep learning, PyTorch. For those fellows that we have that they came to through Ario Data Science, we already have this, experience for Python, machine learning, deep learning. We all do these ones. If you are not actually one of our fellow, I urge you need to provide these to make sure that you actually catch up. Also, we are familiar with PyTorch in our deep learning class. So NLP versus LLM. So if you look at this one here now, we know what is already about, AI. AI is the general umbrella here. You can see that. And then we have machine learning, right? We have the field of machine learning, and then we have the field of NLP. But now we have intersection from deep learning and NLP. We have, LLM, and then we have the NLP. So what we are going to do is, NLP basically apply rule-based system and machine learning to process text. But LLMs, large language models, apply, the deep learning for knowledge comprehension and stuff like that. So this is basically one of the key things you may say when somebody asks you what the difference between NLP and large language. So NLP basically use the olden techniques, including rule-based, but LLM does not use rule-based systems. It uses basically deep learning techniques. And, some of this stuff you can see here, we have, about natural language processing, data requirement. We need to structure data for NLP, but for large language models, the data we need is unstructured, right? You just give the models land data. And for NLP, low model can run on local machines. For NLP, you can use local machine, but for large language model, you need GPU, you need, all those stuff, right, to run it. So these are some, comparison between large language models and NLP. And by the end of this course, you will be able to have the key foundational, techniques or concept for NLP and LLM. And, you're going to have your knowledge you learn to basically do some other stuff, such as, fine tuning and, and other stuff. And then at the end of the day, you're going to use all the things you learn to, build at least a small large language model, a toy large language model from scratch. So this is basically one of our objectives. But just to make this, it's only when you put more effort. If you put more effort, at the end of the day, you will go away from this. Not only what we discuss in the class, the key things we will have is that when we give you assignment, when we say you read this stuff, go and read them, read the books, and you will take very good stuff away from this class. These are some of the key things we're going to discuss. Foundation, transformers, advanced topics such as ethical NLP, and then we'll also be discussing assigning you some papers to read, in the class. These are the course, I think, some of the books I've already made mention. These are some of the reference book, speech and language processing, building large language from scratch, enhance all large. These are all the things we share in the GitHub repository. Also in NLP, we do publish in conferences and journals, but if you are from academic, I must tell you this, that we from computer science, even though in Nigeria, you see people saying you publish in journal, but in computer, most importantly in NLP and AI, the top field to publish your paper is conferences. Yes, this is something different from the traditional field that we know. For example, maybe chemistry, physics, where we say journal carry more weight. You publish in a journal is more better than conference. But in AI, in our field, in NLP, top venue is conferences. And some of the conferences are this ACL, EMNLP, NACO, Calling, all these are top conferences. But also these our journals, they are also good. But don't be deceived when somebody, or you said you publish in a conference and someone say, no, the conference is not a good venue. So that's not that. But also in our own case in NLP and our field, we have what we call, not a conference, but also we have conferences, workshops. So workshops are second tier, not as prestigious as conferences, but our workshop in NLP, they are even better than journals in other fields. So they are also competitive. And this is when you start, you can start submitting your paper to journal, to workshops. When you now learn how to do everything, you can now submit your paper to, conferences. So we have workshops, which is very place to start submitting your work as somebody that just started your work. This is just the beginning, telling you the starting point. We also have a place where we publish papers in NLP, which is called ACL Anthology. So if you look at this one, if you are looking for papers for NLP, this is the best place to look. You can see the venues, AACL. We have what we call ACL events. These are the top if you want to publish paper in NLP at a conference, aim to publish it here. One of these. This is a top venue. We call them ACL events. ACL event, for example, ACL, EACL, EMNLP, all this one are most, but we also have non-ACL event. You can see them, all they are also good. But here you can see for each paper, you can see the years. And so this is a good reference to get people. You already know what is archive. Archive is where you be able to get like papers for NLP. So in archive, we call our papers for NLP computation and language. So all the papers under computation and language, they are papers from NLP. Yeah. So this is basically the introduction of what we normally have. I want just you to know some of the things we have in NLP. But then what is natural language processing? Who can tell us what is natural language processing? So it's a subfield of AI that focus of understanding and generating text, right? That's NLP. It's just a field of AI because everything now is AI, but NLP is subfield of AI that focus of understanding and interpreting or generating human text. But NLP is divided into two. One of the things that it divides, we have what we call NLG, and then we have what we call NLU. What is NLG and NLU? NLG and NLU. Can you, am I sharing my screen? Hello? It seems my screen.
Yeah, I think you stopped sharing, sir.
Oh, sorry, wait. This. Okay. That, okay, let me just do this. Okay, what can you see? Is it which window can you see? Can you see it now?
It is in presenter mode.
Oh, okay. So let me turn this one from presenter mode. Screen, use slideshow. Okay. Yeah, can you see slideshow?
Yes, sir.
Huh?
Yes.
Okay, cool.
Yes.
So what we have, I said we have what you call NLU and NLG, right? So what is NLU? NLU is basically, extracting meaning and, from entities, and NLG producing coherent text from given stuff. So where we can see that we have what we call natural understanding, and then we have natural language generation. Natural language understanding, for example, if I give a text and try to say sentiment analysis, find the opinion in this text. Is it positive or negative? This is what we call natural language understanding, because you are understanding the text. It's NLU. If I give you text for hate speech and this is hate, this is not hate. This is NLU, natural language understanding. But NLG is language generation. So an example of that is, for example, all these, machine translation. You're given a text in this to translate this. This is called generation. You generate. So you need to know the difference between them. NLP and NLU. So this is an example of them. NLU, you can see them. Sentiment analysis, question answerings, machine translation, summarization. All these are NLG, natural language generation. Given a text and translate to another is natural language machine translation. Summarization, given a text, large text, and you summarize it to, small part is, what we call natural is part of natural language generation, right? So these are the two things that you should know. We also have some tags that are basically hybrid. Some of them are hybrid of the NLU and NLG, but I believe now you have the idea what is, NLU and NLG. We also have what we call natural language processing and computational linguistics. So these two things are also somehow used interchangeably. Some people will say computational linguistics, some people will say natural language processor. But both appeal, they have, they have some kind of similarities. So NLP, we call it NLP, natural language processing. Computational linguistics, they call it CL. So what NLP does is that it builds practical applications that solve real world. That is natural language processing. But people from computational linguistics understand human language works using computational method and models. So they understand human language, right? That's people maybe from linguist people. They try to understand the language. How do we understand the language? How do we produce the language? How do we learn what all those stuff, right? But people from NLP, they build speech recognition system, they build machine learning system, machine translation system, they build chatbot. These are NLP people. But linguistic people, what they basically do, they try to understand the language. That is why it is called computational linguistics. Right, computational. They are trying to do linguistic computationally. However, we people from NLP, we are trying to process the text. That is what we call natural language processing. So this is basically one of the key things about that. And then we have linguistics, as we know, the study of language, right? This is what we have already said. Those people that are doing computational linguistics, they are mostly people that works on language. So for computational linguistics, we have different kind of stuff, phonetics, phonology, syntax, semantic, all these, they are subfields, but we don't build them. So, but why field of NLP is interesting. Nowadays, everything has changed to NLP. NLP is changing the world. In fact, things have changed. Even those people that are in computing, they are proud that, I can program. This person cannot. Now the vibe coding is here. With LLM, you can build and ship, build a good system in a way. Even if you have not finished it, it can take you far. So NLP has, revolutionized, and we have, a lot of languages around the world. For you to understand one language from another, for example, machine translation can really help, to do that. You can see, for example, in Africa, we have over 2,000 languages in Africa, right? So you can see that in Africa, if we have 2,000 languages, how can we communicate? How can we share some experience commonalities? So these are some of the key things that makes NLP interesting, because it solves problems that allow people to do that. For example, people can do question answer, and even if it is not on the language I work on, I speak for example, you can do sentiment analysis. All of these are empowered by NLP. But before you build NLP system, you need, high quality data and text, but the world language, 70 are not equally represented in digital media. So what do we mean that before you have any system that is NLP system, such as ChatGPT, you typically need to have that language has enormous amount of data. For example, English has enormous amount of data in the world, but compared to Hausa, compared to, Fulfulde, compared to Kanuri, you cannot build a ChatGPT like for Kanuri, mainly because you may not have that kind of data for Kanuri, similar to, English. So before you need build, NLP system, you must have a lot of corpus to build that stuff. So, what is corpus? So a corpus is basically a structured collection of data that you collected that can be used. And basically, corpus, we have very small amount of corpus for low resource languages. For example, for Hausa, as I made mention, we have very limited amount of data. So that's, the relationship between corpus and low resource language. But how do we collect this data? Number one, we see expert curated data. Sometimes we collect data manually. For example, you can, go and, collect all the text available written in Hausa. Number two, open web data. You can crawl, data from internet. For example, Wikipedia, for example, Twitter or Facebook, you can crawl data. So these are some of the approach you can collect data. So for us to build any language models, NLP model for any language, you must collect data for that. So for example, in Africa, we have many, team people that are working to curate African data, such as Lamfrica, and also some of the entities that funded data creation for African languages, including Lacuna Fund, basically have to create, funded data creation for African languages. We also have what we call under resource here. Language has been classified into what we call six categories of language based on the data availability. We have what you call, if you look at this one here, we have, class 0, we have class 1, we have class 2, we have class 3, class 4, class 5. Meaning class 0, these are languages that they don't have no all-level data text. 80% of the languages in the world, they are of 0. Then we have 1, 2, 3, something like that. So this categorization, we have what we call high resource languages. We have moderate resource languages. We have somehow resource languages. They call them hopefuls. So high resource languages, which are called winners, meaning these are, whenever you see high resource languages in NLP, we mean languages such as English, Chinese, that they have high amount of data. So in this paper, this guy named them winners. Then we have someone, they are called moderate. For example, Russia, Korean, they are moderate. We have hopefuls, somehow resource, Swahili, Turkish. We have low resource, they call them scrapping by. So this low resource, for example, Hausa, because you don't have amount, extremely low resource, such as Wolof, Tigrinya, they call them left behind. So you can see that we call these languages with different names depending on, what kind of data they have. So the highest one, the language with many data, they call them winners, and the languages with low resources is called left behind, scrapping by, left behind languages. So this is some of the categorization that we use for those. And then the rest, languages with virtually no detailed footprint, those languages that they do not have, any data available. Many indigenous and endangered languages like Shadiak languages, Amazonian languages. One of the key things you should know is that if you look at this is an example of web crawl data. So Common Crawl. So Common Crawl is a data archive. So all the data on the internet have been scrapped by Common Crawl. So Common Crawl is one of the repository that crawl all the data available on internet. And then all this data, you can see the percentage of this data on internet is 48%, 45% are English. You can see that's why you see all these language models, they are very good in English, 45% English. This is German, French, other European, Russian, Chinese, Japan, other Asian. But where is African language? Arabic, 0.6% Arabic. But where is African languages? Despite the fact that 30% of the world languages are African languages, African data is 0.05. What do you mean? African data, what do you mean by African data? All those over 2,000 languages, put together, their data representation in Common Crawl data is 0.05. This tells you that low resource African languages, they don't have enough amount of data to actually, do modeling. So one of the key efforts people are doing right now is how can we create data for low resource African languages. This is one of the things we have been doing as part of our research, creating many, many data for African languages. For example, Hausa, Yoruba, and Igbo. Okay. Any question before we proceed? If you have a question, you can also put them in the chat. So let me take a water. Give me like 2 minutes to have a water and come back.
when post like a Ghanaian, when women deal with period, pregnancy, menopause, what the fuck do men deal
okay.
with?
So I'm back. So where can we get the recordings? So we basically upload all the recordings in our YouTube channel. So immediately after this class, hopefully we'll upload the recordings. So so why NLP is hard? Why is NLP hard? So one of the key things, that makes NLP hard is one of them is ambiguity. Yeah. So there is a lot of ambiguity in language because human language is very complex, right? What you may say here, for example, I can say something to one of my friend, and basically, it may mean different thing, right? So that makes language more ambiguous. So in this case, for example, let me take an example. This is an example, right? We have what we call lexical ambiguity. The bank is closed today. Does the bank refers to a financial institution or the side of the river? Because bank, when we say bank at some point, it means, side of the river, right? So you can see that is a syntactic ambiguity. Example, a sentence can have more than one valid structure. I saw a girl with telescope. I saw a girl with a telescope. What does it mean? This can mean different things. Let me show you. Possible meaning, I used a telescope to see the girl. I saw a girl with the telescope. It means that I myself, I use a telescope to, see the girl, right? Another possible meaning may be, the girl is the one holding the telescope. All these meaning are valid, right? So you can see what we call syntactic ambiguity. There may be possible meanings with the same sentence. So you see, this is the something you can see. Who had the telescope? I saw the girl, right? Or it can be this. The girl is the one. I saw a girl with telescope. It can be this or this. So this is actually a problem. Ambiguity in language as well. I ate food with spoon. I ate food with spoon. Now, with, it means the tool you use to eat. But what about I ate rice with curd, with ingredients served together, right? Means here, with, it means the ingredients served together. I ate rice with Muhammad, with a person ate together with. You can see here, this is all ambiguity in language. So all this stuff. So you can see, with here, it means different things. So this makes ambiguity. We also have semantic ambiguity. Semantic. The chicken, a sentence can have more than one meaning because it depends on the context. The chicken is ready to eat. Possibly, the chicken is going to eat something. The chicken is cooked and ready to be eaten. So you can see all these. When we try to do modeling for language, how can we make sure that the context, the interpretation is exactly what we mean? Even human can, have an issue in, having the, the context matters. You must put the context to understand something. There is also pragmatic ambiguity, meaning depend on context, social norm. For example, can you pass the SAL? To interpretation. Literal, are you able to pass the SAL? Asking about ability. A polite way to say, please pass the SAL. When you say, are you able to pass the SAL? It's just a polite way to, say somebody if you. So all this one, what makes, NLP ambiguous. So how do we overcome these language challenges? How? So these are some of the, we provide tools to interpret the meaning, resolve ambiguity using text, context, a large data set. So for you to be able to resolve ambiguity, to make sure that all the context is understood, you need to get large amount of data for particular language and train a model so that that model can understand all the ambiguity, all the context, particular word is used, all the context, everything it comes with, right? So you need to understand all those stuff. And in this course, inshallah, we hopefully be able to look into how can we build modern NLP, for example, using transformers, using large language models, LLM, to understand all this contextual information. Okay, what's the time now? Okay, we still have 48 minutes, 1:48, okay. I think we may need any break. Let me just continue. Okay, so we have just seen what is NLP, what is different kind of NLP. For example, we have NLU, NLG, and we have seen why NLP is difficult, some of the challenges. But despite these challenges, the field of NLP was able to overcome it in such a way that now all these contexts have been taken care by when you train your large language models. But understanding semantics is very difficult in NLP. We have different kind of, NLP layers. Number one, we have morphology, part of tagging, chunking, parsing. All these one are NLP stuff. What is morphology? I will quickly go through this because this is some of the basic. For today, we are just showing you the basic, building blocks for NLP, as we start. So it's just a study how words are formed. This is, called morphology, and help computers understand how words are built together in each case. So we have different kind of, morphology. We have inflectional morphology and we have derivational morphology. So this is something that you may not be quite interested in because this is something related to linguistics, but it is good for you also as you start building block of the course. When we talk about morphology, it just study how words are formed and from structure, such as, for example, prefix, suffix, and root word. So all this one, the study of all this is what we call morphology. There is inflectional morphology, for example, changes the form of word without changing its core meaning. That is inflectional morphology. For example, walk, walked, cut, cuts. We didn't change anything that. But why do we care about this in NLP? We care about it when we come to what we call tokenization. So in NLP, when we have a particular word and that word has multiple meaning, for example, walk, walked, cut, cuts, a particular word has multiple meaning. So in NLP, if you want to do any processing, you need to bring that back word into its core meaning. That is its root meaning. So if it is work, whenever you see work, you need to do what we call lemmatization or some way to change it back to work. So if you see any word cuts, so you need to do lemmatization and change it to root word called cut. So this is basically why we care about this. We have derivational morphology, which create a new word. For example, with teacher, teach, teacher, kindness. You can see it's not like adding something new. So also this one, we need to learn, for example, embedding, because if derivational, because this word mean this word. So whenever you see this and this, you need to associate them, they mean the same thing, and that's when we have what we call embedding, which help us to do that association. We discuss this more. Morphology, we also have another thing called morphology. Morphology is, we have what we call languages that are morphologically rich languages. What we mean by this, morphologically rich languages such as English, Chinese are referred as morphologically poor languages, and such as Turkish are morphologically rich language. Now, what do we mean by a language when we say it's morphologically rich? What do we mean by when a language is called morphologically poor? So, in morphologically poor, it means words stay mostly the same. They don't change. Minimal meaning comes from word order, fewer total words from. So you can see here, I go, you go, we go. Maybe mostly the same. We only change he or she, but in morphologically rich, when you want to say I go, when you want to say she go, everything is different. So that's what you call that, so they have verb changes extensively. Yeah. And many prefix and suffix, and this is what we call morphologically rich language. So for example, this is, I think, in, we have Hausa Swahili. You can see here, I will go, you will go, and whatsoever. You can see here we have different kind of start, Zan, Zamu, Zaka, Zashi, Zata. You can see that. Or like, here we just change you, he, she, right? So this is what we mean by morphologically rich language. And for example, in Swahili, you can see here the go, change it, tender. You can see the verb here changes a lot. So this, what we mean by, morphologically and poor and morphologically rich language. But why do we care about knowing what is morphologically rich and morphologically not rich language? There are several things. Number one is morphologically rich language creates thousands of word form. If a language is morphologically rich, so for a single word, it may have multiple words. So how can you associate each word to one word, to say wherever you see all those words, it means one word? So this is one of the key problem for that. In NLP, don't forget today we are just doing the intro, and this intro basically we are just talking about some of the basic stuff that will help us to learn. Today is not, we are not talking about any building anything. We are not also talking about any models, but just talking about some of the basic, because this is our first class. We all know what is word and token. So wherever you see a token in NLP class, it's just a unit of text. So for example, of word, we know is the smallest meaningful meaning. A token can be either words, can be subword, or even a character. So for example, here I have a word, this is a word, this is a word, this is a word. But a token can be a single character. You can see it can be words, can be subword, can even be a character. That is a token, depending on the context. So whenever you see a token or word, they have different meaning in NLP. So this is, for example, I love NLP research. Love words, meaning you can see I love NLP. All these one are token, right? These are all tokens. And what we normally do is we have some what we call tokenizers, which will basically divide sentences into tokens. So here we have word level tokenizer. So word level tokenizer, I have this sentence, I love NLP research. We have tokenizer, which take a text and divide it into different, pieces. We have word level tokenizer. It will take a text and divide it into words. We have subword level tokenizer. It divides, we call them BPA. We'll discuss this later. I love NL, divide into P and research. We'll discuss this idea differently later. But just to tell you, in NLP, we have a process called tokenization, where it takes a sentences and divide those sentences into group of words. That is what we call tokenization. Okay. Yeah, we'll discuss these tokenizations in details, but just to let you know, we have what we call word tokenization, subword tokenization, character tokenization, and sentence tokenization. So sentence tokenization, given a paragraph, for example, it will divide the paragraph or whatsoever into sentences. That is a tokenizer. That is why we say token is, can be a sentence, can be a word or whatsoever. Character tokenization, it will take, for example, sentence and divide it into token. And word tokenization, it divides the sentence into word. Subword, it would divide them not only word, but also subword. We'll discuss this later when we come to doing tokenization. Before you train your model, you need to do what we call tokenization. So we'll discuss this more in detail. And then I don't want to discuss, no need to discuss all this, detail now, but let's look at it. This is word tokenization. Given this sentence, you can see that it will divide this into I love NLP. This is what we call word tokenization. Why is this interesting? Because for anything, before you do any NLP task, before you do it, you need to tokenize your text. So why is tokenization even important? Let's just pause. Can somebody write to us in the chat why tokenization is important? Just type, why do we need to tokenize text in NLP? Can somebody tell, right? Or you feel free to unmute and tell us, why do we need to tokenize text? Why do we need to tokenize text? Anybody with the answer? Why do we need to tokenize text? All right. Okay.
My name is Buhari.
Hello,
yeah, so I can see somebody, Yahya Abdurazak. He said we use tokenization so that we can convert the text into embeddings. Yeah, so this is one of great answer. So let me just tell us, like, now, when you have a bunch of text, we know this bunch of text, our models cannot read this text the way it is as character level, right? For example, when I want to train a model in Hausa, the models, they are mathematical models. They cannot understand our characters. If I write Aboki, it cannot understand Aboki. It cannot understand Shamsuddin, right? Model cannot understand because they are mathematical models. What models understand? Who can tell us what models understand? What do models understand? Yeah, the text is a string, so we need to encode. That is another, good way, encode or embed it. So we need to convert this string into, embeddings, sequence of numbers, 0, 1, and whatsoever. But before you do embedding, so we need to do tokenization. We need, given a text, you need to convert each word into token, and now take each token and convert it into equivalence, sequence of, representation, numerical representation, or we call it embedding or encode it. So that's why we said word tokenization is very important. But because of its importance, we have different kind of tokenization, right? One of the approach is what we call word tokenization. It takes a text and divides it into word level. That is word tokenization. But another, we'll discuss why all these are important. But another one is subword tokenization. One of the algorithm, for example, in BAT, use what we call byte pair encoding, and byte pair encoding use what we call subword tokenization. Why? Because if I have a text, a word called unhappiness, right? Unhappiness. Subword tokenization makes sure that it takes the word and divide it into those that are those words that we know and those that are actually combined together. So for example, in byte pair encodation, which is subword, it will divide this, take this on and happiness together them, and play, it will take play and do this. This is what we call subword tokenization. For example, this is another algorithm called word piece algorithm that was used in BAT. So it will take this play and this the list last part, it will put hash as index, as prefix. But don't confuse about this. We'll discuss this more in detail. But just to tell you what this is, we have character tokenization. It takes characters here and divide it into character level. So this is basically we have sentence tokenization. I love NLP. It is exciting. You can see it. Take this and do this, right? And this is useful for summarization and translation. When you do want to tokenize, you don't talk for machine translation and also summarization. You don't tokenize, like, for example, word for word, because you need to take, like, the whole sentence and tokenize it so that you will, if you want to do translate, you will translate the whole sentences rather than translating the word by word, right? So this is really helpful. So these are some of the, stuff we have. We also know how what is called part of speech tagging. This is NLP task. I'm just telling you some of the NLP tasks. Part of speech tagging is NLP tasks that tag attach tag to each word. For example, if this is he ate an apple, you say this is a verb, this is adjective, this is tags in NLP called part of speech tagging. We have what we call chunking. is also another NLP task that attach find the static structure of text. Let me jump this one. So let me quickly go into some of the tasks we want to solve in NLP. We have different kind of tasks. Understanding tasks, for example, text classification, name entity recognition. All this one are NLP tasks, which is understanding NLU, natural language understanding. We also have NLG, natural language generation. These are some of the tasks we have in NLP, and we'll learn more about them in the future. We have speech and multimodal tags, for example. All these one are NLP tags that you can learn later. Yeah, so these are some of the basic NLP tags we have already talked about, such as tokenization, subword removal, stemming, which, if you have a word such as cats, you change it to cat. Where you change it to original. Running, take the root word. This kind of tags in NLP, we call them stemming. Why stemming is important? Basically, as I told you, when we are trying to train a model, we want to select the fixed word. Yeah, we will share the slide. We also have lemmatization, which is basically similar to that. Similar to lemmatization. So I think this is the end of this slide. But more importantly, I think is that these are some of the few tags we have seen in NLP, but we may not actually cover, explain more in more details. But what we do is we will assign some readings for you to understand. Let me share the screen. The basic NLP. Okay, so as part of this, what we have free is that we want you to, as a starting point, just for understanding the field of NLP, we give you a reading here. You can see that the first reading is natural language processing state of art. Natural language processing state of the art, current trend and challenges. This one, when you read it, it will basically give you an idea. What is the state of NLP? What are the opponents field that you can leverage? If you are starting your NLP field, reading this will give a very broad idea what is NLP. For example, you can look at what we talk about, morphology. You can see syntactic, all this stuff. You can see them. You can see the history of NLP, related work. All these stuff. You can see them. Future of this. So this is some of reading that we want you to take. As I said, we are here. We are not forcing everyone to be here, but somebody is asking, is the class going to cover mathematical deep aspect of NLP or coding? Yes. So we have coding aspect, for example. For each class we come, for example, how longer you can see practical. We have exercise. You can see that for PyTorch, training, embedding, sentiment analysis, attention mechanism. You can see it's Colab. Pre-training LLM, you can see Colab, fine-tuning, everything we have, practical aspect, but we are starting now. So, at the end of the day, as I said also, this one is basically, this one is also a course that we did for EMS, but we are going to update this one as we go with the slide and everything. So this is the first one. Number 2, there is another paper that I want you to read, The Rise of Africa NLP, Contribution, Control, and Community Impact. So this is a paper from one of the PhD students, which I co-supervised writing. We basically look at the NLP progress in African languages, what is happening, what are some of the key, open field. So you can go through that. But also I will add this one with our paper for those people that are interested in House NLP, which basically House NLP progress. We have a paper, I will add it also. You can see one of our paper, House NLP, current status, challenging and future direction for House language processing. So in this paper, basically, you see we discuss a lot of field, what are some of the fields that, need some research direction for House NLP. So this is actually another good area, good paper that we will update. And also, I want to make sure that today, to introduce you some of our, people that will help us to go through this one. The first one, we have engineer. Are you here, Abdul? Yeah. So
Yeah, I'm here.
yeah.
Can you hear me?
Yeah, we have Bala Mariga Abdjalil. He's here. He will be the coordinator. Everything you want to ask, reach out to Bala Mariga Abdjalil. And also, I want to introduce our program, curriculum coordinator in person, Lukman. Lukman, are you here? Lukman, are you here with us?
Yes, I'm here.
Okay, Lukman is here also. He will help us, with, practical classes. We also have Palalu. Palalu, are you here?
Yes, Doctor, I'm here.
Okay, so we also have Falalu. So they will help us with doing the practical class. So when we do the theoretical class in the, theoretical class with slide and shows, then we're gonna have, we're gonna have the tutors to help us to do the labs, and everything is there, but they will explain the lab. So for each slide we do, for each lecture we do, we have corresponding, practical tutorial to cover it. Yeah. So this is basically the introduction. We're gonna cover a lot as we go, including the mathematical concept. We're gonna go deep, but today is basically the introduction. And I urge you to go and read, what I've already shared, the papers I've shared. Please go and look at them so that you'll get grasp of, the introduction of NLP as we have done now. Okay, any question again? Okay, so yeah, if there's no question, please do join our Discord. In our Discord, ask any question there. We're gonna share materials there. But if you have any question, please do join our Discord. We share the Discord link. If you can join the Discord link. Yeah. Engineer, share the Discord. Okay, this is the Discord channel. Let me share it again. So this is the Discord channel. If you haven't joined, join the Discord channel, and then you can ask questions in the Discord channel. Yeah. All right. So thank you very much for joining, and we see you guys tomorrow. Bye-bye. Thank you.